Here are the answers to a multiple choice quiz B. 5 problems were an issue: 13, 10, 17, 5, and 3. So the first question gives you a scatter plot and says, which of the following points is most likely a high leverage point with respect to regression? So I can understand why this was an issue, because high leverage point is not vocabulary you hear a whole lot. But what this means is that which point would be influencing the line of best fit the most. And there are two types of ways of labeling different types of points. Influential are set off in the x direction, and outliers have large residuals. They're both highlighted on the plot above. This point here has a big gap in the x direction with respect to its next closest point, and then points that are far above or below the regression line are considered outliers. Of the two, influential points will move a line a lot more. So this is the influential or the high leverage point. So the correct option is the point 5.1, 105, or choice A. Next question gives you output from regression and asks you to interpret the value of 6.8 from the table above. 6.8 appears in the variable row, not the intercept row, so we know that -5 is the y-intercept and 6.8 is the slope. The sentence you should have memorized is that each additional unit increase in the x is associated with an increase of slope value in the y. So slope is 6.8, or delta y over delta x. Y was the ERA, x was the WIP, so every 1 unit increase in WIP is an associated increase, because it's positive, of 6.8 in the ERA. There's the interpretation. The correct answer is A. So the other options are wrong because C and D talk about intercepts. E would be an interpretation of r squared, and B is a slope interpretation, but it has the x and y backwards. I would suggest always writing your slope like this so that you can match up the units with the numbers. Next question also does more regression and gives you a table of outputs, but this time you have a constant and the square root of items. So in the body of the problem, it says that the original model produced a curved pattern. So what they did was they took the square root for the number of the items, or the x, and it created a linear pattern. So when you do that, you're taking linear regression on not y versus x, but y versus the square root of x. Taking that output and turning it into an equation produces y-intercept, coefficient, and the square root of the input. Substituting in 22, because that's what they asked you about, 22 items, you get 16.056, or choice B. Next question talks about the relationship between two variables, gives you a number for scale, tells you what the correlation coefficient is, and asks you about a different input value. To organize bivariate information, it's probably a good idea to draw a sketch, even if they don't give you data. It says advertised spending is going to be used to predict sales, and they say that the ad spending was never more than $1,000. Even though there was a strong correlation of 0.90, if you use this relationship when your input is $100,000, you are really leaving the area of your original model. That's not advisable. 100,000 is much greater than the values in the experiment. The vocabulary for that is extrapolation. Extrapolation is never a good idea. Making predictions for outside the range of your information is not reliable. And finally, in the last question, another bivariate situation. Predict number of units sold based on the amount of money spent on marketing, and which is the following best graphic to evaluate the appropriateness of the model. So if you take those two variables and put them in a display that we normally would, you would think a scatter plot would be the correct issue. You can take money spent on marketing and use it to predict the number of units, but scatter plot isn't one of the answers. After you do a scatter plot, it is often common to do a regression line, and then to test whether or not your line is appropriate, which is this question here, you would create a residual plot. So the best answer is C, a residual plot. The issue with the rest of them is that dot plot and histograms are for univariate data, or in other words, you just have one variable to look at. And box plot and bar charts primarily consider themselves for categorical displays. That's it.